Good afternoon, everyone. My name is Anthony Wood, and thank you for joining me this afternoon. Today, we're going to talk about preparing your game and your schedule for multi-platform development. All right, so who am I? My name is Ant Wood, and I'm an indie dev who's been indie deving since about 2010. In that time, I've made several mobile games and then a bigger console game, Damsel, which is my baby, and I love it. And I got to port that all on my own, which was really, really cool. My first port was in 2014 with Defiant Development's Hand of Fate. I worked as a member of the studio for that game, and it was a really great opportunity to learn about all of the different things that are involved in porting a game. And it was quite successful too, so that's really good to have your first game be something that was quite successful, knowing that you're responsible for a pretty integral part of it on some platforms. I've been porting games pretty regularly now as a freelancer since 2016. I've worked mostly on Unity ports, although I am doing a Game Maker port at the moment, and we're looking into Unreal Engine as well. In that time, I've ported 10 games about across about 19 platforms. So most of the time, you won't just port to one platform; you're going to port to multiple platforms. All right, so what are we talking about today? We're talking about porting games. That's essentially, for our purposes today, taking a game that you've built on PC or Mac and making it run on a commercial game engine like Unreal or Unity or Game Maker, and hopefully in the future more as well. So, who are we talking to? So, hopefully, you're a developer and you're making a commercial game with a piece of middleware like Unity, Unreal, or Game Maker Studio. And this is for everyone. If you're responsible for systems, content, and production, I've got some tips in here for all of you to make the game run well on those platforms and also to make the porting process easier for a third party porting engineer who might come onto your project. But if you're using a bespoke engine or no engine, there's a lot of content here that will still apply to you, although timelines and scales might be a little bit different. But if you're writing your own game from scratch, um, you're probably aware of a lot of the things, or I hope you're aware of a lot of the things that we're going to talk about. So, what are you going to learn? Well, I hope that you'll learn that there are a lot of things that are required for you to consider when you're creating a production schedule. Porting is something that touches every system in the game. It's not something that you can just get someone to do at the last minute and then give it back to you. It's a process that's very involved with you as a developer, and there's a lot of back and forth because every game is different. And I'm also going to talk a little bit about how to architect your game to make porting easier for you and for people like me. And a lot of those tips actually are just very general, good software development practices. We're also going to talk a little bit about how to set up your assets, make some middleware considerations so that you can understand your options and your choices there. So, we're going to be talking about commercial consoles today: PlayStation, Switch, and Xbox. Unfortunately, a lot of the information that's specific to those platforms are hidden behind NDAs. So we won't be getting into anything specific today about those platforms. You can take this as general advice. If you are an approved developer and you want more information, you can, of course, contact me and we can work something out and I can help you. But just be aware that we won't be discussing any particular method for any particular console today. This is general advice that's going to apply regardless of the console that you're working on, and also regardless, usually, of the engine that you're working with as well. All right, so the first thing I want to talk about is what actually a port is. It comes from portable, and it's the act of taking a software system and making it run on a platform that it wasn't originally designed to be run on. And that can happen at different levels. There's the application layer where you would take a game that you've designed in Unity and make it run in Unreal or Game Maker Studio. Then there's the system or operating system layer, and that's taking something that's been designed in Windows and making it run on Mac OS or iOS or Android or Xbox OS. And then there's the hardware layer as well. So we are taking something that was designed to run on x86 code and porting it to run on ARM code. A lot of that process has been taken care of. Engine manufacturers are really good at a lot of that stuff, so it's not as scary as it sounds. Uh, it does require actual intervention, though. Someone does need to do your port. It isn't a one-click process like some people might lead you to believe. Sometimes it's really easy to do a port, and sometimes it is really hard to do a port. Like I said, commercial engines have done a lot of the work to make this a seamless process, but seams still remain, and I think that they will remain for a long time. These are dynamic environments. Consoles change their requirements. Unity changes direction. Unreal changes direction. There's always going to be some level of coordination required there. So today we're going to talk about porting games to consoles and more broadly to mobile. But consoles more specifically, and that involves work on the OS and the hardware layers. We're not going to talk about moving from one engine to another. The other thing that we need to think about is how consoles now aren't just something that sits on your living room, on your TV cabinet. These consoles are connected to giant ecosystems, and the people that make these consoles want you to use those ecosystems. In fact, in a lot of cases, they require you to use those ecosystems. So that's things like cloud saving and achievements and being able to share your gameplay with photos and videos and things like that. So you just have to keep in mind that we're not just making it run on a different box, we're making it run in a different world. All right, so let's talk briefly about why you might even want to port your game in the first place. The obvious answer is that you're going to greatly expand your audience. Porting your game is fundamentally a business and marketing decision, and you want to reach as many people as you can. There are a lot of people that own Xboxes and PlayStations that don't own a PC. You can involve yourself in the console wars and the PC master race if you like, but if you're making games for people to consume, you want to have as wide a reach as possible. Um, there's something weird about the closed nature of consoles that makes it feel special when you release on one. That you can release on Steam and that's cool, but being on Xbox, and I don't, it's not a real thing, but it's there, and it kind of makes you feel cool. If you grow up playing Nintendo and you finally have a game that you designed on a Nintendo, that feels kind of cool, and we can't discount that. Another thing that porting your game to consoles does is it forces you to make a better game. There are a lot of rules involved in putting your game on one of these consoles, and beyond that, it makes you think about the quality. You don't want to spend all this money to get your game running on a console if it's a middling crappy game. So it really forces you to take that extra care to make sure that you're putting out something that's worthy of the console. That's you want to rise to meet the quality of the other games that you're selling amongst. At least you want to rise to meet that level of quality, if not exceed it. The other reason you might want to do a port is because your publisher wants you to. They have marketing and business needs as well, and they're thinking about all of the different places to sell your game. And it's often a relationship with the publisher that will prompt you to start thinking about porting. I want you to think about it long before you've secured a publisher. That's the reason for this talk today. We want you to really start thinking about how it's going to run on different platforms from as early as possible. That's going to make your publisher happy that you've considered it, and it's going to make the process easier once the porting begins. Okay, so you have realized that you want to port your game. When do you start thinking about that process and how to incorporate it into your schedule? The answer to that is really simple: as early as possible. Porting touches the foundations of your game, and you want to understand what those foundations will be before you start putting too many things on top of it. You need to understand that small choices, seemingly small choices at the beginning of a project can balloon out into dramatic consequences later on, and it can be expensive in terms of money and in time. So we really want to eliminate those surprises early on. Don't think that you know the impact that a design decision is going to have. Don't just assume that you know what that impact is, regardless of what it is. Uh, you should always be thinking specifically about how it's going to run on the different platforms. The other thing is that the platforms that the game is played on are going to inform core design decisions in your game, especially around things like interaction. If you've made a mouse-driven game, how is that going to work with a controller on a console? And these things are really important that you need to think about. All right, so you're an indie with no budget and you want to know what you can do right now to make sure that your game is more suitable for porting. So what you can do today is to start playing your game with a controller as early as possible. That's probably the biggest thing you can do. Get that working. Is your game fun to play with a controller as well as a mouse and keyboard? Do things like button prompts show up correctly? You want all of that functionality in as early as possible. Rebinding is another thing that you want to think about as early as possible. Think about all of the different ways that someone's going to interact with your game. You want to be playing your game with multiple resolutions and aspect ratios to handle all of the different sizes of TVs and consoles out there. It's got to look good on a small Switch screen and some giant 100-inch LED LCD that you've got as well. You want to play with different speaker setups. Audio is really important to the design of a game, and you want to understand how it's going to play with 2 channels on a Switch and some 7.1 surround sound system. Especially if game mechanics revolve around things like audio, you really need to understand how that's going to work. You want to play it on the most potato-iest of potato laptops that you own. You want to see how it runs on a crappy machine, because a lot of game devs are building with these beefy 10th 11 gen Intels with RTX 3080s, and then as soon as they put it on a less capable machine, everything just falls apart. So you don't want that surprise. You want to play on potatoes as early as possible. You also want to play on your big beefy rigs. You want to play it on the most capable machines that you can find, because there are things that can happen on those machines as well. You want to understand how your game's going to perform with that range of equipment. You also want to play with lots of people. If it's a multiplayer game, you want to see how it works on a couch, as well as on a desk. If it's local or multiplayer online co-op, you want to understand the impacts of all of those things. Okay, so what else can you do? Well, you can contact approachable, good-looking porting engineers, and what you want to ask them to do is get your game running in its most basic form, right? It's super early, but let's get it running on a Switch or an Xbox just to see how it's going to perform. The earlier you jump in and start doing that process, the earlier you can discover those weird little things that you didn't anticipate, because you couldn't anticipate. You have to see these things running in the wild. You want someone to do an evaluation possibly for you to see where super technical things are happening. You could get someone to do like performance tests and things like that, that can point out red flags where things might crop up in the future, looking at things like memory management or shaders, things like that. You want to do this evaluation stage as often as practical for you to do. So get a prototype running on device. You definitely want your alpha running on a device, and then obviously your betas as well. At every stage during the production, you want to make sure that you're getting it on to the consoles just to see how things are working. You want to continually keep checking for surprises. Don't run it once and then go, it'll be fine in a year. You want to always be doing that process. It's vitally important, and it will probably save you a lot of money in the future. All right, so the next question you should ask yourself is, what platforms should I even be porting to? And it's not as easy as just putting it on everything. There is things that you might want to consider. A big one is, what are you capable of maintaining? You don't just release a game and then that's it. Especially if your game is big enough that you're putting it on multiple consoles. You want to support that game over time. Perhaps you've got add-on content that you want to put in there. There's going to be some bug fixing and patches that need to happen as well. So you just need to be aware that those things are a consideration, and if they're outside your scope, then you might want to think about going on fewer platforms. Uh, you've got to ask yourself, what can you afford to do? There are things like ratings requirements. If you're going to go physical, like if you're going to have a disc printed, you have to send that off to more than one ratings agency, and that costs money. If you're digital only, luckily the cost is very low there, which means that most indie devs don't have to worry about paying that ratings fee for the different agencies, but it's something to consider. You also have to consider the cost of getting a team to port your game. This isn't cheap. This takes a while. So you need to understand that there. Your publisher's probably going to help you out if you have a publisher, but if you don't have a publisher, you're going to have to wear those costs as well. So just be aware of that. You want to talk to your team as well about how the systems and the interactions work. As we said earlier, you got to think about like a mouse-driven game. Is that going to run on a console? Can you make it run well on a console? Does it make sense to run on a console? So that might limit the platforms that you put your game on as well. So you need to think about that. The biggest example, once again, is mouse-driven or touch-driven games being moved to a controller. They don't just straight port. There is a lot of work there. Technically, just making sure everything lines up again. But then also, more importantly, from a design point of view, if it doesn't feel good to play, you need to really think about that. And if you don't have the resources for that, then consider maybe holding off. There is nothing wrong with releasing your game on PC, seeing how it does, and then moving to other consoles. That if you don't have a publisher and you're just starting out, that's a perfectly valid thing to do. I mean, it's a perfectly valid thing to do even if you do have a publisher. All right, so let's talk about something a little bit more concrete and specific. How do you want to set up your architecture to make the porting process as simple as possible? Well, it's actually quite easy, and it's not specific to porting most of the time, but there's like 2 or 3 big rules that you should probably think about. Uh, you want to use good OOP software engineering practices, so like solid uh, coding practices. Um, it's just generally good advice to follow those rules. You have to understand that when someone who's porting your game comes in, they're going to touch many systems in your game, and if you're using good software engineering practices, you're making that process significantly easier. It makes it easier to debug your game. There's a lot of debugging that happens on the consoles, and it just makes it easier for any engineers that jump into your game to understand how things work. If you follow those best practices, everyone else knows those best practices, and it's just a nice way to maintain that consistency. You also want to look at things like naming conventions and coding style. It's best to have a document ready that you'd give to your other developers. You want to give that to your porting engineers as well. They're going to do their best to maintain the style that you have in your game. It just makes it easier to read. It makes it easier to work with. Of course, not everything is OOP. You could be doing something that's functional, a little bit more low level, but the idea is that you want to keep things abstracted. That's the bigger takeaway there. You want abstractions. Abstractions make things really easy to work with. So examples of that would be, don't call IO directly from the game. You want to abstract it out, because different consoles and different computer systems, if you want to read a piece of information from a file, that file is going to be in different places depending on where you are. So you want an easy way to go read this file without having to decide every time you want to read a file the location that it's coming from. You want to make that process as easy as possible. The guiding rule I have is, in your gameplay code, if you've got those pre-processor directives, if Unity switch, if Unity Windows, whatever those are, if they're in your game code, that's probably not a good idea. You want them abstracted out somewhere. so that you can just go, read this file and get the information back. It makes optimizing your game easier. It makes it easier to understand, and it makes it easier to change. Don't rely on directly talking to things like middleware either. So something with audio cues. I worked on one project where audio cues were really, really, really important, and NPC characters would react based on the audio cues that they heard. The problem was that they actually used the audio system for those interactions to take place. If it had been abstracted out, we could send those information to the NPCs without actually having to play the audio, without having to use the volume of that audio as signals for the NPCs to do something. It led to some interesting situations where it was really hard to optimize things without breaking core gameplay. So if they'd abstracted that out and gone, there's an audio bark playing here, do something with it, it would have been much easier to solve a few of those problems. It also makes changing middleware easier if you abstract it out as well. Calling play sound is just easier than talking to Wise or Fmod directly. You don't want to do that. It just makes things harder. And something else that you might want to abstract is something like achievements. The code to unlock the achievement is different on every device, including Steam, including GOG, including Xbox and trophies on PlayStation. But if you can just call unlock achievement or set the process of achievement within your game code without having to worry about the platform that the achievement's going to be unlocked on, you're going to make your life a heck of a lot easier, and you're going to make your engineer's life a hell of a lot easier. So that's the first big thing that you want to think about. Abstract everything. Within reason, don't go too crazy, but you want to think about abstracting everything just to create that little barrier of distance between your game code and the underlying systems that are using it. You also want to think about things in terms of being asynchronous. Okay, so a lot of the time you can't just call and get your information back directly. There could be some cloud save that you're dealing with. You're waiting for some response from the OS to come back, so you can't just go load this file, give me the information. So plan around things being asynchronously handled. It's always a good idea to load up everything before you need it. Don't just load things on the fly, and don't load up things from your disk every time that you need them. It's okay to load something into memory and just keep accessing it from there. So you want to rely on callbacks that are sending back basic pieces of information. The array of byte is it gets passed around a lot. So learn how to use it. That's a good way to pass information. And yeah, so this applies to anything that involves communication with the OS. Save games and saving any sort of information is a really big component of that. Something else that you might want to do here is not save all the time. You don't want to keep writing out to your hard drive. Some teams I've worked with save the game or save their settings every time they change the volume on a slider. That's a bad idea. You don't want to do that. And on some platforms, you're actually going to fail your certification because you're writing and reading from the memory too often. You don't want to do that. All right, so let's talk a little bit about the assets that you're going to create for your game and how to understand those assets so that they work best on multiple platforms. The most important thing that you can do as a artist or a programmer, or if you're touching art, you have to understand the import settings. You should know what you're doing when you change them, adjust them. Different compression types, different sampling types, things like that. You should understand that. Have a play, experiment, see what changing the different settings it does. See the effect that they have on the game. Change assets, do builds, and see the effect that it has on build sizes, because build sizes are important. People want to download your game. They don't want to download things that are inefficient, or a lot of people don't. People pay for their internet. You want to make that as nice to them as you can. One thing you should probably think about doing is making the raw assets as large as practical. it could be that during the development of your game, 4K becomes the standard or 8K becomes the standard. So think about that before you start and make things as big as possible, right? And then what you can do is you can use the import settings to shrink it back down for that particular platform. If you're going for Switch, maybe you want those import settings to be smaller because of the small size of the handheld screen. There's things that you can think about there. So make things as big as practical, and then use import settings to make them smaller. One thing I see often is artists not using powers of 2 for their texture sizes. It helps compress things better. It makes everyone's life a little bit easier. So create your images, UI, sprites on a texture that is has dimensions that are a power of 2. 2 by 2, 4 by 4, 4 by 8, 256 by 1024, 2048 by 1024. It makes it easy to compress. It makes it easier to work with those assets. Think about atlasing things. Unity does it automatically. I'm not sure about what Unreal does at the moment. Their 2D system isn't necessarily as good as Unity's, from what I understand. So you want to, but you want to use those. You want to use those systems that are available to you. Pack your sprites into atlases, either automatically or by doing it yourself in your in Photoshop or whatever you use. You want to think about codecs for audio. So, Switch, we have Opus NX, which is a hardware level decoder, and XMA on Xbox. So you want your audio to be in those formats because things are just going to run a little bit better, especially if you've got a really complex game. You want everything to be using as little resources as it has to get the job done. So one weird thing that you're going to want to think about, especially with Unity, is build determinism, right? So every build isn't necessarily going to have the same layout of code, and that might not seem like a big deal until you want to patch your game later on. So a patching process may incorporate a lot of doubled up code just because things are in slightly different orders. To get around that in Unity, you're going to want to utilize addressables or asset bundles. They're kind of evolutions of the same idea. And that will start packing up your assets into deterministic chunks that can be compared really, really easily across builds. While we're here, keep all of your old builds because you might need them to create patches later on. You could have engaged a porting team, but they're long gone. But you want to put out an update. It's actually not that difficult to do a lot of later on updates if it's just a small amount of code or a couple of assets. It's quite easy to rebuild and submit. So you want to think about that. So keep all of your builds. So yeah, just a little note on determinism that you might want to keep in your mind. Another thing you want to think about is third-party assets. So anything that you might download from an asset store. These assets might not necessarily have been made by people who understand the limitations or the requirements of consoles. They might create things with, huge poly counts, really complex shaders that they developed on their beefy PC that might not run on Switch. And these things can be wildly unoptimal, and they can even break systems and get really difficult to debug. So think about your third-party assets. And what I'd suggest is you don't want to use a third-party asset to fill a gap in your knowledge. You want to use a third-party asset to fill a gap in your time, okay? So you want to understand what that third-party asset does, even if you didn't create it yourself. So you try and avoid just throwing systems in your game that work and you're using them because you don't understand how they work and you want that piece of functionality. Make the effort to understand how that functionality works, and then use that third-party asset to save yourself some time. Don't use it to save to fill in your gaps of knowledge, because it could come back to bite you later on. One thing that you should really think about is the impact of your experiments and how expensive they might be. So don't rely on experimenting with something like post-processing to make your game look good, right? The attitude that we're going to make it, we're going to make the game and then we're going to make it look good is a dangerous one. Your game is how it looks, so you want to make sure that you have a really specific intent with your design choices, including how things work. Post-processing is really expensive on some consoles, and a lot of teams reach the end of their development time and go, oh, we're going to put on all of these filters to make it look good. Don't do that. The way your game looks is part of your game design, and you should be thinking about that as early as, or if not just after, the mechanics that you're implementing. All right, so let's talk briefly about middleware. So we distinguish middleware from other assets by its function. So assets usually just sort of make up part of your game, whereas middleware sits below that and is a much more fundamental system. Things like audio, like Wise or Fmod, or for input, for example, in Unity, you've got the new input system, or Rewind, or In Control. All of those things I would consider middleware. I would consider even the Unity packages middleware to an extent as well. So a lot of the time, you'll download that piece of middleware and it won't come with any functionality for dealing with Xbox or PlayStation or Switch. That's something that needs to be added on. Most of the bigger middleware providers have done that work for you, and you just need to get access to those extra parts that they provide. The process that you usually go through is that you would contact the middleware provider and say, look, I need access to Xbox or PlayStation, and they will contact Xbox and PlayStation to see if you're an approved developer, and then they'll give you access to that information. Now, as a porting team, we have access to all of those plugins already. We've gone through all of that work for you, but it still makes sense that you want to get access to those things as well. It makes sense because we're putting that code into your repository. It's being stored on your systems. So you have taken ownership in some way. So you're going to want to be an approved developer so that everything is appropriate legally for you to have that code. So start that process of talking with platform holders. Even if you have a publisher, even if you're talking to a porting team, you want to talk and become an approved developer as well. Be aware that these additional middleware might have a fee attached to it. It may be an extra $1,000 to run on Xbox, and then another $1,000 to run on Switch. So keep these costs in mind. Most porting teams aren't going to foot those costs for you. You're going to have to make those expenses yourself. So look into that pretty early. Maybe even buy those licenses early to avoid surprises in your budget later on. The other thing about middleware is that you can get into a bit of a place where dependency hell starts poking its head up. Things are compiled for specific versions of the console SDKs that we work with, which are compiled for specific versions of the Unity engine or Unreal Engine that we work with. And then the middleware is compiled for specific versions of the SDK and of the engine version. And if you move one of them, you have to move all of them up most of the time. So if you're jumping from 2019 0.4 LTS version of Unity up to 2020 or 2021, there's a lot of updating that has to take place, not just for the engine, but for the SDKs that run the consoles, and then the middleware that they use. It all gets dragged up. So you want to get to a place where you're not going to upgrade your engine unless you really, really have to. If you can, with Unity, hit that LTS version, 2019.4, 2020.3, and you want to stay there and stick on it, unless something really important requires you to upgrade your version. Most of the time, you won't have to upgrade your versions to submit patches in 6 months, 12 months time. You can still submit with the versions that you ran with. But if you haven't submitted your game, be aware that those SDKs may even expire after a certain date, and you'll have to upgrade anything before you want to submit to the platform holder. So, if your game runs over, there's a very real chance that you're going to have to upgrade everything before you submit. So just be aware of that. Dependency hell can get complicated very, very, very quickly. So just manage it. It's probably worth having a spreadsheet or some repository of information so that you can keep track of version numbers. All right, so let's just take a brief moment to talk about dev kits. So, dev kits or development hardware are modified versions of the retail Xboxes, PlayStations, and Switches that we get our hands on in order to develop and test the game. You can't connect any debugging to a retail unit. We need special units that do that for us, and dev kits usually will differ in that they might have more ports or connections on the back for better communication. They've often got a faster CPU, maybe more RAM or bigger hard drive space, things that just make the process a little bit easier um, to cushion the blow against some of those bigger bugs that we might be dealing with. Uh, and as a rule, your game must be tested and run on physical hardware before it's submitted to the store. That's so that the console owners can have a little bit of peace of mind that you've actually done that work there, but also because there are some things that are just not possible to see in action unless you're running on that development hardware. Things like unlocking achievements or saving the game. These systems only work on the hardware, and so you need that hardware to see how it's going to work. Uh, so the only problem with dev kits really is that they're quite expensive, maybe 4 or 5 times the cost of a retail unit. And if you're spending, 2 or 3 years making one game, you don't necessarily have much incentive to buy the dev kit yourself at your studio. So that's why you're going to hire an external porting team. We have all the dev kits. We have multiple dev kits. So if you've got multiplayer, we're set up to do that. You often are going to need multiple dev kits for this as well, so that's even more expensive. Unfortunately, we're not allowed to share them. I can't even show you a picture of them. They're all covered by contractual agreements, but they're not that hard to find if you're in the industry and you want to go and talk to someone. What we might often do is, if practical, we'll come and see you with our hardware, or you can come and see us, and we'll put you in a couch in front of the game so that you can see how the game is working, because your designs should also be tested on real hardware as well. Each console exists in its own environment, and you want to make sure that things work in that environment. So there's just a quick note on dev kits for you. They're super expensive. You don't need them, but we do, and that's what sort of makes our job a little bit more specialized than some other services that you're going to get. I should mention that you can buy your dev kits if you're an approved developer. I recommend that you do if you can afford it. It's nice to be able to play your games on that dev kit hardware and see how it's working. You can get a little bit more forensic with your analysis to make sure that things are working. One big thing about porting is we often don't know if something's broken. So it's really good if you point that out by playing the game. If it doesn't look dramatically broken and no one's pointing it out, it often goes unnoticed. And the best way to combat this is for you to sit down and play the game on yours or our hardware. All right, so let's talk a little bit about certification. So certification is the process that games must go through before they're allowed to be released on the platform stores. So every game must pass a platform-specific certification. So for every platform, there's a different certification process. And it's there to ensure that the game meets minimum standards for presentation, optimization, and error handling. The certification process usually consists of dozens to hundreds of specific test cases that need to be run, and they are often manually run. Someone actually sits down and runs through all of those test cases. But the most important test case is always game performance, or general performance and stability, right? It's not covered by any of the other tests, but if your game crashes or frames per second drops down, you're going to fail certification if these things are really dramatic. Crashes especially. If your game crashes, you're going to fail certification. So a publisher will often get an external QA to run all of the certification testing for you before you submit it to certification. Our porting studio will go through every certification test and make sure that they're passing before we submit it to certification. So you just need to be aware that there's hundreds of tests that your game needs to pass in order to be put on the market for sale. These days, there's not a fee to go through the certification process. In the past, that was different. You could spend thousands and thousands of dollars to get your game certified. These days you don't have to, although there could be some fee for like expediting your certification if you're in a hurry, but you don't want to get in a position where you're in a hurry. Um, you have to be really aware that certification isn't a QA service. You can't keep throwing it into certification to find out what's wrong with your game. They'll get upset with that, and you might find that there are ramifications there. So you need to make sure that the game is good to go before you submit it to certification, because you're probably going to fail certification anyway, so you want it to be with as fewer things as possible. Um, each specific certification attempt can take multiple weeks, and they could be weeks where you're sitting around twiddling your thumbs waiting for some results to come back. And you're going to most likely submit multiple times. Okay. Um, this means that you can't polish up your console builds up until release day. A lot of people, the Steam process is really easy to publish a build of your game. And so you might be under the impression that you can do that on console as well. That's not the case. You need weeks for a build to go through that process. So you need to understand that you can't just leave things off and you'll get to them before release. It all has to be done. You don't want to rely on day one patches, because you can't guarantee that day one patch is going to be available on day one unless you submit it early enough. So you can't just go, oh, we're a week out, we're getting a couple of bad reviews from another platform, let's try and get this patch in. It doesn't work like that, unfortunately. I would suggest that you allow up to 8 weeks between when you consider your game done and when it will go on sale, and that 8 weeks is there for you to go through the certification process multiple times. If you're planning on launching your game simultaneously across multiple platforms, that 8 weeks is going to be surprisingly tight. We try and get things back and start working on issues as soon as we hear about them, but there's a lot of work in there, especially if that release deadline is fixed, right? There are also a lot of things that you can't do until your game has been approved, in regards to like storefronts and things like that, pre-order discounts, any of the business and marketing considerations that you need. You might need weeks for those processes to be completed, and you might need your game to be certified before those processes can start. So just be aware that this can take weeks and weeks and weeks, and include that in your schedule and budget for that accordingly. There's a lot of people that think they understand the rules of certification, like they've worked on a project and they were working on some piece of art and it came back and said this is right or this is wrong, or they heard something from someone. Very often people will come to us and go, we've just been told that this thing is going to fail certification. A lot of the times, that's just not true. You really need to read the rules yourself, right? Don't just take people's word for it that something's going to pass or fail certification. You have access to those documents, and so if someone does say, look, this is going to fail, press them and say, do you know what specifically it's going to fail? If they can't tell you that the certification that it's going to fail, they might not be as familiar with the rules as they're letting on. So go and check it out for yourself. Usually certification rules, well, not usually, but they can be very subjective. You have to understand and maybe argue over some semantics. It's surprisingly close to what I imagine being a lawyer is about a lot of the time. So you can argue over what does this mean, but we can contact account managers and we can get things like that cleared up. But the bigger point is, don't trust anyone. Don't just take people's word for it that something might pass or fail certification, especially if it impacts your design. You want to understand the rules before you take people's word. So go and check it out yourself, and see if you actually are breaking it before you expend resources trying to fix something that isn't a problem. All right, so that concludes what I would consider a very super high level overview of the porting process. There is just so much more information that just doesn't fit in 40 minutes, but I hope that I've touched on all of the main points that you need to consider when undertaking porting. It is a specialist task that is usually done by specialists. It's one of those things where you learn the lessons as you go, and so we bring all of that experience to the porting process. If you want to talk further, my email is anthony@screwtapestudios.com, and I'd be happy to delve further on a one-on-one basis if there's specific questions you need answered. So once again, thank you very much. I hope you enjoy the rest of the conference, and hopefully I'll talk to some of you soon. Bye.